Morning, ma'am. I am S. Madhu from CSCB section. Today, I am going to give the video presentation on the topic Encapsulating Security Payload. Going to the topic. Introduction to Encapsulating Security Payload (ESP). It is a component of the IP sector protocol used to provide confidentiality, integrity, and authentication for IP packets. It primarily encrypts the payload of the IP packets, ensuring data privacy during transmissions. ESP is essential for secure communication over untrusted networks like the internet. We can see in the picture IP security encapsulating security payloads. It contains several blocks of IP header, ESP header, rest of the payload, ESP trailer, authentication data. And ESP header means it has a security parameter index and it is with the sequence numbers. And ESP trailers is with a padding 8 bits with a padding length, etc. Purpose of ESP in network security is the premier goal of ESP is to protect the data from eavesdroppings and tampering. It ensures that only authorized parties can access and modify the transmitted data. ESP supports both transport mode and tunnel mode for different security requirements. It means that the main goal of ESP is to protect the data. When we are transmitting the data, some eavesdroppings will occur. So that to protect the data and to access the data or to modify the data, the ESP in network security is used. We can see the picture and modes of ESP operation. Transport mode encrypts only the payload and is used for end-to-end communication between hosts. Tunnel mode encrypts the entire IP packet, suitable for VPN gateways and site-to-site connections. The choice of mode depends on the security needs and network architecture. We can see the IP section mode, a transport mode, and a two PCs. The data can travel from one end to another end communication between the hosts. And in the down, we can see a tunnel mode. ESP packet structure. An ESP packet typically consists of header, payload, optional padding, and a trailer. The header contains information necessary for processing, such as security parameters, and the payload is the actual data being protected, which was include higher layer protocol data. The ESP packet structure consists, we can see the picture, a security parameter and a security number, payload data, padding, authentication data. In padding, a padding length and next header. This is the structure of a ESP packet. Going to the next slide. Encryption algorithm in ESP. ESP supports various encryption algorithms like AES, 3DES, and others for data confidentiality. The choice of algorithm depends on security requirements and performance considerations. Proper key management is crucial for ensuring the effectiveness of encryption. It means that ESP has follows several algorithms like ASC, 3DEC, 3DES to keep the data confidentially. The the choosing of the algorithm depends on the security requirements and performance consideration. And in this, a proper key management is very crucial to protect the data or to encrypt the data. Going to the next slide. Integrity and authentication in ESP. ESP provides data integrity and origin authentication using authentication headers or integrated with ESP. Integrity checks ensure the data has not been altered during transmission. Authentication verifies the identify identity of the sender, preventing impersonation attacks. And the integrity checks ensure the data. It means that when the data is transferring from sender to receiver, some data is altered. So the integrity will check that whether the data is altered or not. And the authentication means it identifies the sender and preventing from some attacks. Going to the next slide, we can see the picture and key management and security associations. ESP relies on security associations to manage encryption keys and parameters. Security associations are established through protocols like Internet Key Exchange. Proper management of SAs is critical for maintaining secure and synchronized communication sessions. We can see the encapsulating security payload picture, and the ESP follows security associations to encrypt the data or to encrypt the keys and parameters. And the security associations will follow some protocols like Internet Key Exchange and the to maintain the security and synchronized communication system. Advantages of using ESP. Encapsulating security payload provides comprehensive security features including confidentiality, integrity, and authentication. The main features of ESP is that confidentiality, integrity, and authentication. It is a flexible and can be used in various network configurations and modes. ESP supports scalable and secure remote access, making it popular for VPN implementations. It means that ESP is a very flexible and it can be used for different network configurations and different modes. And ESP supports scalable and more secure remote access, making for VPN implementations. The main aim of ESP is to keep the data confidentiality, integrity, and authentication and the data safe. And the limitations of and challenges of ESP. Proper configuration and key management are complex and critical for security. ESP does not protect routing or IP header information unless combined with other protocols. The performance overhead due to encryption and authentication process can impact network throughput. It means that key management is very complex, but it is very useful for security. The ESP is combined with other protocols and protect the information. Going to the conclusion, ESP remains a fundamental component of modern network security protocols like IP security. Advances in cryptography and hardware acceleration continues to improve ESP performance. Ongoing research aims to enhance ESP's security features and integration with emerging technologies. Thank you.